Okay, today we are going to discuss in today's class would be the types of motions, in which we are going to discuss what is circular motion, what is oscillatory motion, what is vibratory motion, what is periodic motion, what is non-periodic motion, what is random motion, and obviously one more topic that is going to be a combination of any of these two motions. All right. Now, let's start with what is circular motion. Let's read the definition. A body in which a moving body, a motion in which a moving body moves in a circular path where the moving body is going to change its position constantly. Now look at the motions or examples which I have given over here for circular motion. If you look at the sun and the planet, or if you look at the earth and the moon, all of it is changing its place, from moving from one place to the other, and the whole of the earth is moving from one place to the other when it's moving around the sun. And similarly, when you talk about the motion of the moon around the earth, the whole of the moon is moving around the earth, and this kind of a motion where the whole body is moving from one place to the other, or it's changing its position continuously and constantly, it is known as a circular motion. Okay, now let's go to the next one. The next slide is that we are going to discuss. The next motion in the next slide is oscillatory motion. Now, in this kind of motion, a body is going to move repeatedly to and fro and change its position continuously with respect to a fixed point. I will read. In this motion, a moving body repeatedly moves to and fro and changes its position continuously with respect to a fixed point. Now, if you are looking at this pendulum, this is a very common example again. The motion of a pendulum moves from here to here, here to here. So to and fro, to and fro. And this is one part of it is fixed at one particular juncture. So that is why in oscillatory motion we say that it is moving with fixed at one particular point over here and moving to and fro like this, going like this, covering like this. Okay, now next one, this is again a wall clock that you have it, which is not used very commonly nowadays, but I think the other name that you must have heard about it is known as a grandfather's clock. Okay, now what happens is you're having the watch over here in which you can see the time, and below it is fixed a pendulum. Okay, now what happens is when there is like it's a 10 o'clock or it's a 12 o'clock, this wall clock over here chimes, that is it makes a noise. And हमेशा जो motion आप देखेंगे इसका, ये इधर से इधर like this, completely going like this. Okay, so to and fro, to and fro. When you see this kind of motion, it is known as an oscillatory motion. Okay, now next example that I have given here is of that of a swing. It is fixed at one particular point, that is this point, and what happens is we sit over here, push ourselves back, then go up, then come down here, then go up like this. So to and fro, to and fro. So when you have this kind of part and particular type of motion, it is known as an oscillatory motion. Okay, now in the next slide we are going to discuss what is vibratory motion. Now, a motion in which a body repeatedly moves to and fro about a fixed point without changing its position. Now, what do you mean by this? In oscillatory, we also studied it was a to and fro movement about a fixed point, but the body did not change its position. Okay, that means that it was just hanging at one particular place and moving like this. Whereas if you look at the example over here and the figures that I have given here in this vibratory motion, if you look at a rubber band, it has been attached, or a wire, stretchable wire has been attached across 2 points over here like this. And what do is we pluck on it, यानी कि उसके ऊपर हम अपनी फिंगर को रखते हैं उसे वाइब्रेट करने के लिए. ना क्या होता वो ऐसे ऐसे, it starts moving like this, and this is the vibration that it shows. Now it can be showing about like this. So this is the to and fro for it. Whereas for oscillation, if you remember, it was like this. Again, swing, it was like this. Whereas for vibration, it is moving up and down, and it is not changing its position, whereas it was changing its position in oscillation. Now over here for vibration, is this these are the strings which are present over here. If you pluck on any one of them, whether it's a guitar, whether it's a violin, whether it's a sitar, if you're going to pluck on these particular strings of these instruments, what will happen? A vibration is produced, and a vibratory music is then created by the vibrations which is created by plucking these strings. Okay, now this is called a tuning fork. What happens is, we have a black colored leather pad, okay, and we hit onto that. Now when you hit onto that, आपका vibration कैसे करेगा? It starts moving like this, starts moving like this. That's why it is shown when it's moving, it was here, then moves here, like it is moving like this. ऐसे ऐसे करके ये move करेगा, ठीक है? Now, if you would have been coming to school, I would have shown it to you as to what the tuning fork is. But basically, when you hit it onto a hard object, that is a leather sub object, and it vibrates like this in its own position. Okay, now you can hear it if it is put next to your ears. You can hear the sound of a tuning fork. Now tuning fork are of different frequencies. Okay, now remember that as we hit different tuning forks or different frequencies, we are bound to hear different kinds of noises in it. Okay, and when you are going to put it in your ears, are we clear with that, children? All right, okay, let's go on to the next one. Now, what is periodic motion? Next topic that we are going to discuss today is periodic motion. Now, what is a periodic motion? It says in the definition, the motion which repeats itself again and again at regular intervals of time is known as a periodic motion. Now, let's look at the figures over here. What happens is this wall clock over here, it moves and completes one circle, and then it repeats itself. If you are familiar with टाइम, जैसे कहते हैं आप, दिन का 1 बजता है तो वो 13 क्यों दिखाता है आपके टाइम में? कभी कभार आप डिस्प्ले में देखते होंगे दिन का 1 दिखाने की जगह पे वो 13 दिखाता है. दैट मीन्स दैट the circle, that is the hour hand or the minute hand over here, or the hour hand, is completed one circle like this, and it's starting the second circle motion. So 12 तक आके वो रुक जाता है, और जब इधर से आगे आता है इस तरफ 1 की तरफ, तो obviously 12 में एक और जोड़ेंगे तो 12 + 1 13 हो जाता है. तो 1 बजे दिन का आपका वो बजता है 13 in that watch. Similarly, when you come to 5, if you add 5 to 12, what happens? It becomes 17. ठीक है? Now what it means is you have this motion. Now दिन का 1 जो बजता है वो हमेशा एक ही बार बजता है दिन में, एक बार ही आता है वो, दिन में 2 बार कभी नहीं आता है. That means that 1 o'clock in the afternoon is repeated after every 24 hours. Alright, that means that हम लोगों ने एक फिक्स टाइम इंटरवल दिया है उस इवेंट को होने का, यानी कि दिन का 1 बजे, यानी कि 1 PM बजने का आपने एक टाइम दिया है. दैट इज 24 घंटे के बाद वो टाइम दोबारा आएगा ना. Look at the way that the earth is moving around the sun. अगर हम कहते हैं कि दिन और रात होता है, कितने देर में दिन होता है, कितने देर में रात होता है. Now all this is determined by how much time the earth takes in moving around the sun. ना एक दिन, जैसे मैंने कहा, आज सुबह का 8 बजे, जैसे आज आपका 3 तारीख है या 4 तारीख होगा, when you are going to have these lessons in front of you, the next 8 o'clock of the next day is going to come exactly after 24 hours. That means that at this particular place, the earth where it is right now, it's going to come back exactly after 24 hours at this particular. So time is bound in a periodic motion. Now I think you're familiar with this particular diagram in geography. Okay, now what happens is, obviously the earth is rotating on its own axis as well as it's moving around the sun. it's going to complete this particular motion from this axis to this axis, or from this place to this place, then you have that summer is happening. Similarly, spring happens, winter happens, and autumn happens. It means to say it, ये कहने का मतलब होता है अब मौसम भी जो बदलता है हम लोगों के यहाँ यहाँ पर अर्थ पे, वो भी एक पीरियोडिक मोशन है, वो भी एक निहित रहता है. यानी अगर आप कहते हो कि मई से आपका समर शुरू होता है, ठीक है, let's just assume, I'm not being very particular about the date, but if I'm just saying that if our summer starts in May, okay, that means that in 2021 it is going to start in May. Now for the next year, that is 2022, again it will happen in May only. That means we will have summer only after 365 days, and if it's a leap year it will be 366 days. So this is what I mean, that आप समर को कभी भी 300 days के बाद नहीं expect करते हो, 200 के बाद नहीं expect करते हो. You always expect it to happen exactly after 365 days. Is that clear with everyone? So this is what is meaning of a periodic motion, that it occurs again and again at regular intervals of time. All right, now let's take this discussion to the next slide. The next slide we have it is the non-periodic motion. Now again, what is a non-periodic motion? These motions do not repeat themselves. यानी कि अगर वो एक बार घट चुका वो दोबारा नहीं होता है वही चीज. अगर वो repeat करता है, if however the repeat, then the time interval between them is not regular. यानी अगर पहले बारे में वो 10 सेकंड में हुआ था तो दोबारा अगर वो होता है, if in case it happens, then the time interval may be less than 10, more than 10, but it will never be equal to 10. Clear? Now again, motion of the car on the road. Now why do you call it as a non-periodic motion? It's called non-periodic motion because हम लोग कभी fast जाते हैं, कभी बिल्कुल धीरे जाते हैं, like a snail's pace. So we do not know how fast we are covering the distance in that time or how slow. Like suppose you're caught in a traffic jam, okay, and it's really a very heavy traffic. What happens is in just 5 minutes you have just covered like 5 kilometers, whereas nowadays when you find the times that the roads are deserted, if you're going out to take vegetables or you're going out to take the necessities, whatever is required, what do is when the roads are free, you take the car out for a spin where it is going to cover a huge amount of distance, a very short amount of time. The car remains the same, but again circumstances are going to be different. So when this happens, you are showing that a non-periodic motion is happening. Next is the falling of the leaves from the tree, or the falling of the flowers from the tree. Nothing over here in both of them is said to be repeated after fixed intervals of time. It's not going to be repeated after fixed intervals of time. It can happen whenever they feel like it. Is that clear? And again, leaves are going to fall, flowers are going to fall from the trees only for the plants, but they are not going to fall at regular intervals. Are we clear with this? So when you see these kinds of motion, you say that it's a non-periodic motion. Let's go on to the next slide. Now next slide says it's a random motion. What is a random motion? Random motion is in which the moving objects move on a path in any direction in different durations of time. Like when the particles are moving over here in this particular cube, they might be able to move very faster sometime, they might be able to move very slower sometime. Similarly, if this path is being formed by any particular atom or molecule, it might be formed in a faster time, or it might be formed in a very slower time. Similarly, when the children are playing in the park, okay, or are moving around, what happens? Some of them are going to run very fast, some are going to run very, very, very slow, just like a snail, or some of them are going to be in between, like it's not very fast, not very slow. So you do not determine how fast they are moving. This again is the movement of a mosquito. What happens? Sometimes they are moving like this, then again they will change like this, then again they are going to go like this. What will happen over here for the children also? Similarly, they might come forward, they might turn towards this side, that is the right side, they might turn towards this side, that's the left side. So they can move in any motion they feel like it. When you see these things happening, you say that random motion is being exhibited. Okay, now let's go on to the next slide. Now, next topic, that is the last topic for today, that is a combination of motion. Now, what is a combination of motion? What do you understand by that? Let's go on to the slides to understand it. Now, first one is called, the example that I have given for the combination of motion is a drill machine. Now, this is a drill machine. Everybody knows that. What is this person trying to do? He is holding the drill machine to make a hole in the wall. Now, what is happening? He is moving in the forward direction. So, what is this exhibiting? This is exhibiting the drill motion over here is exhibiting a translatory motion because it's moving in the straight line. But if you look at the needle of the drill machine, what is happening? Is it going like this? Is it going like this? It's going like this, and then only it is going to drill a hole in the wall. Are we clear with this, each and every one of you? Okay. So what happens is a drill machine, if you take it, is showing two motions. One, it is moving forward to make a hole in the wall, and the needle over here, which shows translatory motion, and the needle over here of the drill machine is showing rotatory motion. Are we clear? So it is a combination of translatory because it's going right into it to drill a hole into the wall, and the second one is the needle is moving in a round rotatory motion so that it is able to enter and make the hole successfully with the drill machine. So that is why whenever drill machine is being asked about or talked about, you have this particular motion that both translatory and rotatory are being shown over here in this drill machine. Now, the second motion again is the motion of a bicycle. Let's read the write-up that I have written over here first. While riding a bicycle, its wheel shows two motions. What are they? It shows translatory motion, which is moving forward in the straight line, and it also shows rotatory motion, where the wheel is fixed, is moving around a fixed point. Now, all the vehicles that are moving on the road or wherever they are moving will always exhibit two motion. That is, they will exhibit translatory motion as well as rotatory motion at the same time. If you look at it, when you're riding a bicycle, are you moving forward? Definitely you're moving forward, but you are seeing that there are two wheels attached to a bicycle. If you look at the motion, they are fixed at this particular juncture over here at the rims like this, and then they are going around like this. It's going around a fixed point. That means that it's rotating around this particular point over here. So the bicycle is moving in the forward direction, showing the translatory motion, as well as the wheels are moving like this and are showing rotatory motion. So we see that we are seeing the most translatory motion as well as rotatory motion being exhibited at the same time whenever we are talking about the motion of a bicycle. Now, let's discuss, and since we have come to the last slide of today's class or today's PowerPoint presentation, let's talk about the motion of a spinning ball. What is the motion of a spinning ball? Now, this is the motion of a spinning ball, okay? It is going to move forward, definitely. It's going to cover and it's going to move in a translatory motion, but when it's moving forward, it goes around like this or rotates about its own axis and spins, okay? So what happens? This ball that is being delivered by the spin bowler or any fast bowler is going to move forward, definitely showing the translatory motion, as well as it's going to spin about its own axis like this, okay? Like this, it's going to keep on moving. So both the motions are being exhibited in the motion of a spinning ball. That is, it's moving forward, as well as it's spinning about its own axis. So in the motion of a spinning ball, I'll read the writer. The ball delivered by a spin bowler shows translatory motion as it travels on a straight line path, and rotational motion as well as it spins on its own axis. So straight line path as well as rotating on its own axis. Okay. Now with this we come to the end of today's presentation. Now I want everyone to go through it not once but twice for a better understanding of the topic. Is that clear with each and every one of you? All right, so let's meet again now.